Welcome again, ladies and gents, to another flipped lesson. Today our focus is density, which is something I know some of you are familiar with from your time in earth science. So we're just going to go ahead and kind of expand on what you already know about this concept. So when we talk about density, what we're talking about is the amount of matter present in a given volume of a substance. So we're looking at how much stuff is contained in a certain space. And we can use this equation, density equals mass over volume, to solve any of the mathematical applications of our density questions. So when we're looking at this equation, your mass is always going to be some sort of mass unit. So in our class, we'll always use balances that read in grams, but it could be any mass unit. It could be grams, kilograms, milligrams, anything along those lines. But it will always be some sort of gram unit. Your volume will either be in one of two forms. It'll either be in milliliters, representing a liquid volume, or it will be in something like centimeters cubed or meters cubed, which is representing, a measured volume of length times width times height. So one thing that you do want to keep in mind is 1 milliliter has the same amount of volume as 1 centimeter cubed. So we can convert between our liquid volumes and our measured volumes by using that conversion. So it is important to note that 1 milliliter does have the same equivalent as 1 centimeter cubed. And so if we look at density then, with grams on top and our volume on the bottom, your unit on density will either be grams per milliliter or it will be grams per centimeter cubed. And that will be dictated by whether you're getting a liquid volume or a measured volume. So when we're talking about density, we do a lot of math applications, but we also do some conceptual applications with density as well. So what we can use density to determine is whether an object will float or sink in a given liquid. So for example, we all know in the winter that ice floats on water, but if I take a rock that has the exact same size as that ice, it's going to sink to the bottom. That reason that it sinks all comes down to density. When we're comparing the ice to the rock, if they're the exact same volume, the rock is going to have a greater mass contained in that space than the ice does. So since that rock has a greater mass, it's going to have a density that is higher than water, and it's going to sink to the bottom, while that ice is going to have less mass in that same amount of space. That's going to result in a density less than water, so it will float. So if you're comparing a bunch of densities of different objects, you can compare them to each other to determine who's the most dense, because that thing will always sink, and the least dense then would float. So here's a little visual example of that concept. So when you're done watching the video, I'd like you guys to go ahead and answer the questions in your note packet to get you started on that. So give me a second to pull up that video. Sorry about the delay, the computer is thinking. It tends to do that sometimes. And as you can see on the bottom of the PowerPoint screen, I know that this video isn't the best quality, but it does a really good job of showing you the relationship between Coke and Diet Coke. Assuming I can get that video to work. So the Diet Coke is on the left and the regular Coke is on the right, and he's just placing that into a regular container of water. And so I'd like you to watch what happens when he releases the two cans. If you need to watch this video again, you can go ahead and hit pause and call up this YouTube video if you'd like. You can just search density of Coke and Diet Coke and take some time to answer the questions in your note packet. So if you want to go ahead and hit pause, take the time to answer those questions in your note packet, because we will be going over those as a part of class tomorrow. Sorry about that. Let's go ahead and call back up the PowerPoint. Now, aside from understanding the conceptual idea of density, we also have to be able to do math. So one problem I like to talk about is liquid mercury. Liquid mercury, sorry about that. Let me call my pen back up. Liquid mercury is one of the most dense liquids we have. It's actually contained in this cup right here. It's a silvery metal, and you can see that this pool ball is actually floating on that liquid mercury, to give you an idea of how dense that liquid is. So if we look at mercury, it has a density of 13.6 grams per milliliter. What volume of mercury must be taken to obtain 225 grams of the material? Just like with our dimensional analysis problems from yesterday, with these word problems, we need to identify where are we going and what do we have to start with. So when we look at the problem, we want to solve for volumes. We want to know what volume of mercury we're going to end up with. It gives us the amount of grams that we have to start, and it also gives us the density. So there's two ways that you can tackle this problem and you can get to the exact same answer, and I'm going to show you both. You can choose whatever way you like, whatever one makes more sense to you. So the first way you can solve it is using the density equation. So we know that density is equal to mass over volume. So if I look at the problem, I have my density and I have my mass, so I'm solving for volume, so I can replace it with x. So my density, I'm going to put 13.6 grams per milliliter. I'm going to set that equal to 225 grams, which goes on top because that's my mass. And then my volume is what I'm solving for. So if we think about algebra, we have to get the x off the bottom, so we can go ahead and cross multiply. So we end up with 13.6x is equal to 225. We can divide both sides by 13.6. And that gets me to x equal to 16.554. And then my unit comes from the density because I'm solving for volume. That means this unit is going to be milliliters. But just like yesterday when we were talking about dimensional analysis, we have to figure out how many sig figs our answer is going to have. So since the 225 is what we're starting with, that's going to be the number that dictates our sig figs. We can see that there's 3 sig figs in that answer, so that means this can only have 3 sig figs as well. So our third sig fig is this first 5. We look behind a round, and it's going to round up. So our answer is going to be 16.6 milliliters. So that's the first way you can solve these density problems, is by using density equals mass over volume. The second way you can do is use dimensional analysis, just like we talked about yesterday in class. So we want to know what volume of mercury is going to be equal to 225 grams of our mercury. So we know we're starting with grams, so we can use this density as our conversion factor. And when you have density written like this, what it tells you is that 13.6 grams is the mass you need to fill 1 milliliter of volume. So if we think about where my units need to go to cancel, I have grams on top, which means my 13.6 grams must go on the bottom to cancel. That means the 1 milliliter goes on top. I've gotten myself the volume, so I can go ahead, cancel my units, and get to my answer. So I would take my 225 and divide it by 13.6, which would get you again to 16.6 milliliters. So we'll do a lot of practice in terms of calculating density in class. Not only do we need to be able to calculate density from a word problem, we also have to be able to calculate density from lab data. So there are 2 different methods that we can use to get our lab data for calculating density of an object, and this is something we'll practice in class tomorrow. The first way is if you have what's called a regular shaped object. And what a regular shaped object is going to be is something like this. It's either going to be cubic in shape or it's going to be a rectangle. It's going to be something that's going to be very, very easy for us to measure using the idea of length times width times height. So we would only use this method if something was regularly shaped. So it was a cube or a rectangle. It's a 2-step process. The first thing you're going to do is you're going to determine the mass by just copying it straight off a balance. So whatever object you have, you just put it on the balance and you copy that number down. What you're going to do next then is you're going to determine the volume by measuring the length, the width, and the height of the object. Now the nice thing is if it's a cube shape, whatever your height is, that's also going to be your length and your width. So you just have to measure once. If it's a rectangle in shape, you'll probably have to measure all 3 sides. So once you go ahead and you get your measurements, you're going to get your length, your width, and your height. You're going to multiply those things together. And then that's going to give you the volume of the object, and you use the density equation to solve that. Now your mass, we're going to go ahead and we're going to measure that in grams, and this will be measured in centimeters. And how we get our unit is if our length and our width and our height are all in centimeters, you're taking centimeters times centimeters times centimeters, which gets you to your unit of centimeters cubed. And it's really important that you pay attention to that. So when we're using our regular shaped object, our density equation will end up with the units of grams per centimeter cubed. Now, what happens if we don't have a regular shaped object? What happens if we have an irregular shaped object? What we're going to do to get the volume is something called the water displacement method. So getting your mass is no different. You just simply put your object on the balance to get the mass. The water displacement method is what we're going to use to get our volume. So what we're going to do is we're going to fill our graduated cylinder with some volume of water, and we're going to write that volume down. So in this case, if you look at the picture that's on your notes, which is also on my screen, our water is starting at 7.0 milliliters. And I have to put that 0 there because it lands exactly on that line. Once you've filled your graduated cylinder and recorded the volume, what we're going to do is we're going to take our random object and we're going to put it in the graduated cylinder without spilling any water. So we want to gently drop it in so it doesn't make a splash. What's going to happen is the water is going to adjust itself due to the volume of the object that we added. So once you put that object in, you're going to let the water settle, you're going to find the new volume, and you're going to record it. So in this case, it's 9.0 milliliters. The difference between those two volumes is going to be the volume of your irregularly shaped object. So this would be what we call our final volume. This would be our initial volume. So what you do to get your volume of your object is you take your final, which is 9.0, and you subtract your initial, which is 7.0. Because we're doing subtraction this time, our sig figs are going to be dictated by decimal places. So the answer here would be 2.0, and our unit is going to be milliliters because this is a liquid volume. So then we can go ahead and we can use our density equation to solve for the density of that object. So density here would be equal to mass over volume. So in this case, our unit would be grams over milliliters. So if you're using a regular shaped object, you end up with your units as grams per centimeter cubed. If you're doing an irregularly shaped object, you're going to end up with grams per milliliter. So that's all we got for density today. We're going to do a bunch of different activities over the next couple of days in class to help you guys become more familiar with this concept. So go ahead now and fill out your Google form and make sure you ask any questions that you do have. Talk to you later, guys.